Hello everybody and welcome to the world of Spark in Azure. This is a session that is part of the Data Platform Virtual Summit 2022. My name is Warner Chaves and allow me to introduce myself. I've been a DBA and consultant for 15 years. I used to work at HP in Costa Rica. Now I'm a solutions architect at Pythian in Ottawa, Ontario. I'm Microsoft Data Platform MVP. Feel free to reach out to me on Twitter at warchav. Check out my blog, createdatapros.com. If you want to reach out to me on email, warner at createdatapros.com. And my employer's website, pythian.com. We have a really good technical blog there as well. Goes beyond Microsoft technologies. We talk about open source, Oracle, data science, machine learning, data governance, and everything you can think of related to data. So, the agenda for today, we're going to do an introduction of all the different ways you can run Spark in Azure. And we're going to do demos of all the different environments. So we're going to go over Spark concepts just to set the stage, the different offerings that you have in Azure to be able to run Spark as a service. And of course, the bigger part of the session is just going to be to walk through the demos. Prerequisites for the session and for learning in Spark, really. Basic experience working with databases and SQL, and some basic knowledge of data warehousing, ETL concepts, or big data. That's all you really need nowadays to not only understand the session about Spark, but to play with Spark itself, because Spark as a service makes it so easy to get up and going really fast with Spark. And we will see that in the demos. You'll see how easy it is to just get up and running. So, first of all, what is Spark? Why should you care? Maybe you're looking for just how do you get on this ecosystem. You haven't really thought about it much, but you've heard about the term Spark. Well, this is the timeline for Spark. Hadoop, for those of you that have been veterans in the industry, Hadoop was released all the way back in 2006, and it was the first big release that allowed a platform for open source MPP parallel processing of really big data sets. Now, Hadoop was a very fragmented ecosystem back in the day. You had to use a different package to run SQL queries, a different package to run like Scala and Java jobs. You had to do different packages to do streaming. So while it was very powerful and a lot of people implemented Hadoop successfully, a lot of people failed with it as well because it was quite cumbersome to install, configure, and to use. Now, 8 years after the release of Hadoop, Spark v1 released, and the idea of Spark was to be the opposite of Hadoop. It was to be one package that you could just use and do your MPP processing, and in the same bundle you could do your SQL, you could do Python, you could do Scala, you could do Java. You would have a familiar data frame API, and you could also do not only regular processing, but you could do streaming at the same time. You could also do batch if you wanted to, which this was separate in Hadoop, and Spark unified it in a very uniform experience if you were a developer or a user. Now, Spark has had intermediate releases, of course. The last major release was Spark version 3, released in 2020, coming up with all sorts of different improvements to the Spark optimizer and to the functionality of Spark itself. And the last release was Spark 3.3 that was released in June 2022. So I'm recording this at the end of July 2022. So this is very, very recent release. Spark has thousands of developers that contribute to its open source package, and not only independent developers, but it also has actual big companies like Microsoft, for example, or Databricks that regularly contribute to the Spark core. Now let's talk about the architecture of Spark. We have a main node runs a program with a Spark context, and through this program we communicate with a cluster manager that helps us distribute the work. So we have a bunch of different worker nodes. This main node is also known as a driver node sometimes. These worker nodes, sometimes they're also known as executors. They run tasks, and a task is anything that goes, fetches data, and then crunches something with the data. And this data can be local, and meaning literally just right there in the same node. It can be remote, or it can even be cloud storage. Now, in the first days of Hadoop and Spark, a lot of people were still doing local storage. So the storage would be right there with the worker nodes. And obviously, this would be very fast in terms of I/O latency because the data would be right there. However, that also meant that compute was coupled with storage, and that was very cumbersome to manage for a lot of people that did on-prem deployments of Spark and Hadoop. But also it would limit scalability, right? Because if you wanted more storage, you had to add more nodes. If you wanted more compute, you had to end up adding more storage, even though maybe you didn't need it. So ultimately, most installations today use remote or cloud storage so that the compute layer is completely decoupled from the storage layer. Okay, and this is the modern architecture of Spark that you will find in most places. Now, if you deploy Spark in the cloud, which is what the vast majority of people do, you will find that most of the storage is just using cloud storage. Now, the clusters themselves, of course, they have different layers of caching that you can make use of so that you're not always going out to cloud storage, but for the most part, the main storage area of Spark clusters today is cloud storage, whether it's that's S3, whether it's Google Cloud Storage, or obviously in the case of Azure, which is what we're talking about today, it could be blob storage or more often now, Azure Data Lake Gen 2. So what is the value proposition of Spark? Why should you care about Spark? Why has Spark been so successful? Well, first of all, it's open source software that is portable across platforms. Before Spark came along, all MPP processing was done with proprietary software and proprietary hardware. This was very prohibitive in terms of cost for the vast majority of businesses and companies around the world. So we're talking about the people that had big Teradata machines, big Netezza machines, big Oracle machines, and this was just simply a huge barrier of entry for people that wanted to do big data. There was just no way for them to afford it unless you had some giant budget to pay for this proprietary software. Now, when Hadoop and Spark came along, it meant to say you only needed commodity hardware and an open source software package to give it a shot and try to do big data. Now, still to today, Spark remains an open source software package. Now, there are some flavors of Spark that have some proprietary bits, but if you stick to the core Spark, then it will still be portable across platforms. Of course, if you move your Spark from, let's say, Azure to Google Cloud, then most likely, not most likely, for sure, you'll have to change all the references to your cloud storage because now you're not going to be using Azure, you're going to be using Google Cloud Storage. But other than that, the core code of Spark would remain the same. Spark also has implicit data parallelism and fault tolerance. What does that mean? It means you don't have to handle or code or do anything special for your Spark queries or Spark jobs to run in parallel or to be fault tolerant. And what I mean by fault tolerant is that a node can have a failure and other nodes can pick up the work. So this happens automatically. Same with data parallelism. The system will automatically parallelize your queries, send different tasks to the different worker nodes. The worker nodes will do the work in parallel, then coordinate with themselves, and then send it all back the results to the main driver node. And again, you don't have to code anything special for this. It is all implicit. Just by using Spark, Spark will handle these bits. It does have multiple programming interfaces, which has made it very successful for adopting by developers, data analysts, data engineers, data scientists, because they can code in whatever they feel the most comfortable with. Some people will code in Scala, some people will code in Java, some people would code in, there's even C# nowadays, there's a Spark, Spark.net. Of course, super popular is PySpark, which is the Python, and you just have to see what you're comfortable with. And of course, also, very important, Spark also offers a SQL interface. So if you are not really a programmer or coder, you can still do a lot with Spark just with SQL commands that look very familiar to what you would be using on a regular database system. Okay? And then finally, Tied to the fact that it supports multiple programming interfaces, there are thousands and thousands of libraries that you can use with Spark. Because, like I said, Spark can execute Scala, Java, Python code, C# code. There are thousands of libraries that you can bring into your Spark clusters. Now, not all of them might run in parallel, but they can still interface with the parallel parts of your Spark code. Okay. Now, as you work through the Spark ecosystem, you will find that there are different flavors of Spark. There's the open source Apache Spark, as I mentioned, that everybody can have access to through the Apache Foundation repos. There's also Cloudera, and Cloudera actually acquired another company that used to do another Spark distribution called Hortonworks. So there used to be these two were separate companies. Cloudera purchased Hortonworks, and now Cloudera still sells their own Spark distribution. The other one that is also a proprietary version of Spark is Databricks. Now, Cloudera, you can run it in the cloud, you can run it on-prem if you want. Databricks is a cloud-only version of Spark that can run in AWS, can run in Azure, or can run on Google Cloud. Okay, and we're gonna see Databricks in detail in the demos because it is a very, very popular way to run Spark. So now that we learned about the basics and fundamental concepts of Spark, again, nothing too heavy, just enough to get us going. Let's talk about Spark specifically in Azure, which is the main topic of our session today. So there's three main services in Azure that you can use to run Spark. The first one is HD Insight. HD Insight was the first service that Microsoft introduced to have a managed experience of Spark in Azure. And it's not really just Spark. HD Insight runs all sorts of different software packages that run inside Apache Hadoop clusters. And we'll see that in the demo. Now, HD Insight is a bare bones experience compared to the other two that are on the screen right now. What I mean by that is when you create a cluster with HD Insight, Azure goes in, creates your cluster, and it gives you access to the cluster. And after that, you're pretty much just on your own. It doesn't have any sort of guided experience. It doesn't have any sort of strong pre-integration setup. It is really just in case you need to run something that is not supported by the other ones, in my opinion, because HD Insight, like I said, gives you a really bare bones experience. Also, HD Insight itself has a big limitation in my opinion because you have to create and destroy the clusters. There's not a way to just simply pause the cluster and come back later on. So again, to me, HD Insight is more of a legacy way to run a Spark and not, or should not be for most people, the first option in terms of running Spark. Second one that was introduced in Azure was Databricks. Again, Databricks is a proprietary product. You have to pay extra to use Databricks. You have to pay for your compute, obviously, but you also pay a cost for using the Databricks environment and the Databricks software. And Databricks gives you a way more richer managed experience, and we'll see that in the demos as well. And then finally, about in the end of 2019, Microsoft introduced a service called Synapse Analytics. And the idea of this Synapse service was that it would bundle the SQL Server MPP engine that is used for distributed processing for big data warehousing, now known inside Synapse Analytics as the dedicated SQL pool, and it would tightly integrate it into also a built-in Spark runtime inside the same service. And this is really powerful because it allows you to have the data warehouse in the full-blown SQL type of engine, and it also allows you to have your data lakehouse capabilities by having Spark strongly integrated with the other product as well. So Synapse Analytics, unlike Databricks is Spark is the only engine under the covers, and really Databricks is built all around Spark only. Synapse Analytics mixes the MPP SQL with a on-demand SQL that works against Data Lake, but still uses the SQL Server T-SQL semantics and the engine under the covers. And it also gives you an open source flavor of Spark that Microsoft has augmented with some bits for integration, okay? So we're going to look at these three on the demo, and you'll get an idea of how the three of them kind of like compare and contrast, and when you would want to use one over the other. Okay. So again, HD Insights, managed cluster. You can pick from different options of what are the bits that go inside the cluster, Spark, Storm, etc. There's no built-in graphic environment. There's no cluster automatic lifecycle management. You have to manually destroy or create. Databricks is proprietary. They're also developers of a very popular project inside the Spark ecosystem called Delta Lake. This project allows you to have more powerful tables than the ones that are available with Spark. Delta Lake tables can do things that the vanilla, let's call it vanilla Spark, does not do. For example, like ACID transactions, like time travel, like zero copy cloning. Also, Databricks has developed heavy optimizations inside Spark specifically to give it more value so that you would want to run Databricks instead of just running Spark. For example, the Photon SQL engine is a new SQL engine that is available inside Databricks, and it was developed in C++ to make it way more efficient, and it also does vectorized processing of data, so it can run multiple amounts of records through the CPU at once, making it really fast. Databricks are also the top proponents of what they call the lakehouse architecture, which means that you don't have a separate data warehouse from your data lake. Instead, you build your data warehouse on top of your data lake by using the Delta Lake tables and being fully integrated with the way that you work with Delta Lake and the querying that you do in a data warehouse fashion. Okay, so this is called the lakehouse architecture. And again, it has a built-in environment, including some ML capabilities, and then we'll see that in the demo. And then finally, like I mentioned before, Synapse Analytics is Microsoft's top analytics service. It blends the Spark with the SQL MPP engine. Microsoft has thrown in some bits on it, and it has the integration with the rest of the workspace. All right, so that's enough in terms of theory. Let's go into the demo and look at these three products in detail. Okay, here is the first experience that we're going to look at, and it's the HD Insight cluster. So I'm going to go ahead right here and say create HD Insight cluster, and we're going to look at all the different options that we get to create HD Insight clusters. Now, of course, you have to select a cluster name. I'm just going to go ahead and say cluster demo DPS 2022. And then we have to select the cluster type. Now, there's a lot of different cluster types. As I mentioned before, HD Insight is not just for running Spark. You can run all sorts of other packages inside the cluster. So you have the ability to run Hadoop, and it'll give you a standard configuration of Hadoop components like MapReduce, Hive, Pig, Scoop, and Uzi. It'll give you Spark, obviously the focus of our session today. You can do Kafka, which is the distributed message processing. We can do HBase, which is a NoSQL database. You can do an interactive query, which basically does the in-memory using Hive and LLAP. We have Storm, which is for streaming, and we have ML services, also known as the R server, which is built specifically for processing R and Python as well. Now, obviously, if you wanted to, you would just select Spark. Once you have Spark, you have to pick the different versions of Spark that are available in HD Insight. So as you can see here, we go from version 2.1 all the way to version 3.1 available in HD Insight. And then you have to just give the different access criteria that you would want for your cluster, and then off you go. Go ahead and click next on storage. Then you would pick what is the primary storage type for the cluster, whether it's Azure Blob Storage or Data Lake Storage. You can select an existing primary account as well, or you can select Data Lake Storage Gen 1. Now this is legacy part of HD Insight because nobody anymore is adopting Data Lake Storage Gen 1. Most people obviously are with Data Lake Storage Gen 2. Now there's some other settings here. For example, if you want to use external metadata stores, you can do that so that your metadata does not live inside the HD Insight cluster, so you can destroy it and not lose your metadata. Okay, but that's pretty much it. When you create the cluster, Then, like I said, you'll have SSH access to the cluster, and you'll be able to interact through the cluster that way through command line. Now you can run some notebook package as well and expose some ports so that you can have an actual notebook experience, but you have to do all these things yourself, and configure all these things yourself is not really an easy to adopt experience. So again, I do not recommend, if you're just going to be starting up with Spark, to use HD Insight. And if you are going to be using Spark heavily in a production setting, I also recommend that you look at the other two alternatives that we're going to check right now: Databricks and Synapse Analytics. Let me close this down. And now here we are with Databricks. So Databricks, as you can see right away, is a full web environment. Let me zoom this in so we can see it better. And Databricks has three experiences: data science and engineering, machine learning, and SQL. And we'll walk through each one of these right now. So first of all, you have the workspace where you can store your different notebooks. You can open the notebook, and obviously you get the same experience that you're used to if you work with different notebooks. You have cells that can be marked down, you have cells that can be code, you have the different languages that you can select: Python, Scala, SQL, or R in the case of Databricks. Inside the workspace, you have your personal notebooks. You also have notebooks that have been shared, or you can import notebooks from other people as well if they send them to you. You have the ability to integrate with source control, so you can store all your artifacts in a source control repo as well. You also have the ability to browse the different data that is in your Spark database and the tables. However, to do this, you need to have a cluster up and running to have access to the table. So this is something to keep in mind here. A lot of the interactivity of the environment with Databricks requires you to have a cluster up and running to access some of these things, right? And we'll look at that in contrast to Synapse Analytics in 1 second. Obviously, compute, very important. Databricks in particular gives you a lot of options of what you're going to run and how you're going to run your Spark. And again, we're going to compare that in a couple of minutes with the experience of Synapse Analytics. But for example, I can go ahead and create a cluster. You can see here I have different ways to run the cluster. There's high concurrency, standard, and single node clusters. If I look at what these means, it says high concurrency is optimized to run concurrent SQL, Python, and R workloads. So if more than one person is going to work on it, you'll want a high concurrency cluster. The standard is recommended for single user clusters. So the idea is that just one person is interacting with these clusters as they're running their data science, their query analysis, or their ML experiments. And now finally, the cheapest way to run, if you're just doing a very small compute and don't need any sort of parallelism, you can actually just run in a single node configuration, which is a cluster that has no workers. So in this case, there is no parallelism, and it's recommended for single users that don't want to spend a lot of money. They don't even need more than one worker node, and they're working on small data volumes, right? Now here is where Databricks gives you a lot of different ways to run Spark. It's what is known as the Databricks runtime. Now I can open this and you'll see there's standard runtimes and then there's ML runtimes that are pre-configured with the different versions of Spark. And you can see in the ML side as well, there's a bunch of different runtimes that have GPUs, okay? If you go to the standard version, you'll see the standard version does not have GPUs. They're in the ML runtimes, and the different versions that are available for Databricks all the way. Databricks really stays up to date here. This is something that is definitely an advantage over some of the other providers. Like in HD Insight, we saw it only came up to 3.1. Databricks stays way more up to date, and we can see it already has a runtime that has the Spark 3.3 version, which just came out last month from the time that I am recording this. Now you can see there's used photon acceleration. This is a preview right now. This is that engine that I mentioned that is developed in C++ and can do vectorized processing of the data. Now you can have auto scaling in Databricks as well, and you can see this is a cluster that automatically will move between the minimum and maximum number of nodes based on the load. You can also set your Databricks clusters to terminate after X minutes of inactivity. Now that's very powerful because it'll save you a lot of money, and it's something that HD Insight does not do. There's no automatic lifecycle management in HD Insight. However, Synapse does have automatic lifecycle management. Now here we can select the worker type. So what is it? There's lots of different configs. You can see there's DS machines, there's general purpose with hard drives, there's memory optimized with hard drives, memory optimized with flash. You can see some that have Delta Cache accelerated. The Delta Cache is another layer of automatic caching managed by Databricks. There's compute optimized, and there's even some other ones here that are newer, that are storage optimized and GPU accelerated, and they are just not compatible with either the runtime selection that I have or with the subscription that I have right now. However, you can see there's a lot of options here. For example, even just the general purpose, I can open this up and there's 30 different flavors of VMs that I can run, all the way to machines that have 64 cores, 256 gigs of memory per machine. The configuration options are pretty mind-boggling. So this is something that is a big difference as well between Databricks, and we'll see in a second with Synapse. Synapse decreases the universe of options that you have for running Spark. There's not that many options compared to Databricks, but that's by design, right? So you're supposed to have a simpler experience, easier to select in Synapse, whereas Databricks really wants to give you all the options in the world that you have for running Spark. And then you select how many workers do you want minimum, how many workers do you want maximum for the cluster, so that if you enable the auto scaling, the cluster will keep fluctuating between the minimum and the max based on the amount of work that is being submitted. Okay, now I'm not gonna go ahead and create it, but something I just wanted to show you. Then finally, Databricks also allows you to create jobs and to create something that's called the Delta Live Tables, which is a way to create data pipelines with Python code into Delta tables. Now, I'm not going to go into detail on this, just to give you an idea though, that Databricks does have a built-in job engine and a built-in data pipeline engine. However, it is all driven by code, okay? Now, the other experience is the machine learning experience, and we'll see it's pretty much similar. We have the workspace, we have the repos, we have the data, the compute, the workflows. However, when we move into this experience, you'll see here I have experiments, feature store, and models. And what happens here is that as you are running different notebooks that use the ML API inside Databricks, then it registers these different artifacts inside Databricks. So you see here, for example, I have an ML example that I was running inside this Databricks environment, and so that registered an experiment. And then I can click on it, and it'll take me to that particular experiment. And you see I ran it a few months ago, how long it took. You can see the source, so it'll save the actual notebook, and it'll save the model that came out of that particular notebook and the different metrics that were part of that experiment that we ran. Alternatively, also Databricks allows you to have a feature store. I don't have one saved here, but a feature store is basically like a table, permanent table that you can use to store the different features that you can then use to train your models, and you can share or reuse these feature stores and reload them with different source data and reapply a model and evaluate the performance. Okay, and this again is all integrated here inside Databricks. Then we also have the ability here to create and track the different models. So you see here, I have a model about wine quality. This is another famous sample that I was working through. And you have seen the versions, and we can see, well, what is the version in staging, in production. So it also keeps track of the life cycle of the ML, right? So this is part of a library called ML Flow that Databricks implements, and then it gives you a graphical interface to go along with it so that you can move your ML models through different stages of the development lifecycle, right? Staging or production in this case, right? So this is the ML experience. And then finally, Databricks has the SQL experience as well. It has a SQL editor, and you can just type SQL here, and it'll connect to different endpoints that do SQL processing from the Databricks interface right here. You can also have the ability to save some queries, and you'll see I have some queries that I have saved here, and it gives you the ability here to just write them. And of course, you have here also the ability to have filters interactively for your results, which is pretty neat as part of that built-in SQL editor experience. And you also have the ability to have dashboards as well. So I'm going to go here into sample dashboards. You see this is a full gallery here. I have one loaded. And you can see here I have this dashboard right now that is populated through the Databricks SQL endpoints, right? So I have a SQL cluster underneath that is computing here the values that I see from my dashboard. And you can actually go into here, look at this. You can download it as a CSV, as a TSV, as Excel. You can view the query that is used to generate that particular visualization as well. And then open it up, and you'll see here how the visualization was generated. Okay, and then you can pin it back into the dashboard, right? So this is a way to create dashboards again and share them as well easily inside Databricks. Now, this, in my opinion, is a really cool way to really easily share visualizations with colleagues, but it's not really a full-blown BI tool. Okay, so while it is very cool and it's very useful if you want to do visuals and just quickly share some dashboards and not get out of Databricks, this, in my opinion, is not a replacement for, let's say, a Tableau, a Click, a Power BI, etc. Okay, so just something to keep in mind. All right, then we can see here, we have here the different SQL warehouses that we will be running as part of our Databricks SQL experience, right? So these specifically only work with this SQL language and this SQL experience that Databricks has built, okay? So keep that in mind. So we have 3 different experiences all built here into Databricks, but all of them under the covers are all built inside using Spark, okay? All right. Now I'm going to switch over to Synapse. And Synapse, again, is different than Databricks. The whole focus inside Synapse, it's not just Spark everywhere. I'm going to show you here. I'm going to go to Manage, and you'll see we have different runtimes that we have inside Synapse available for running our workloads. We have SQL pools, which can be serverless. They can be dedicated. The dedicated one is paused right now. And this is the MPP SQL engine. And then the topic of today, we have the Apache Spark pools. And you'll see my demo pool right now, it's paused. It's a memory optimized, and it has a small size with 5 nodes. Now I'm going to go ahead and create a new one. Now, I'm not going to actually create it, but just to give you an idea of what I meant when I said Databricks gives you way too many options compared to Synapse. But for some people, this might be good. Maybe they don't want to select among 50 different types of nodes, right? So you'll see here node sizes. Well, I'll just give it a name. The Spark Demo DPS. There we go. Now the node sizes. Oh, my name was too long. Let's remove that. All right. The node size is just 2 options: memory optimized or hardware accelerated. And then the actual particular nodes, they don't have 30 different configurations, or it was even more than 30 because there were different families: storage optimized, memory optimized, etc. So unlike what Databricks does, Synapse just gives you here 1, 2, 3, 4, 5 different sizes, and that's it. You select from these. Small goes from 4 vCores, 32 gigs, all the way to double extra large 64 gig vCores with 432 gigs of RAM per node. These are massive nodes. If you need a cluster, a Spark cluster that has this amount of RAM and cores, it's because you are truly doing big data, my friend. Now you can set them to auto scale as well if you want, and you can set a min and a max, just how you can do that in Databricks as well. And you'll see here we get the number of nodes, 3 as the minimum and 10 as the maximum. You also have this option to dynamically allocate executors if you can enable it or disable it. This is a Spark option so that Spark can use dynamically more executors as it's running a query. Now, I'm not going to create the particular Spark cluster here because I already have my Spark pool already created. So I'm not going to do that. Just going to cancel that, discard. Then if we go into my demo pool, you will see how it is. It was configured, and you can see here the automatic pausing is enabled. So Synapse also does automatic pausing. Number of minutes idle is 30, so this cluster will go to sleep after being idled for 30 minutes. And you can see the Apache Spark version of this cluster is 2.4. Now again, if I go ahead and create a new one, additional settings, you will see here. Okay, so this is the automatic pausing, the minutes idle, and you can see here the Apache Spark version right now available in Synapse. So you'll see the latest is 3.2, is not 3.3. So again, Databricks is usually more aggressive in bringing out the latest versions of Spark. Okay, so that's how you create a new Spark cluster in Synapse. Again, the main focus here that I want you to take away is that Synapse is not just all about Spark. Obviously, it's also a lot about SQL. It's also a lot about running pipelines, for example, graphical pipelines. And Spark is just a component inside Synapse, right? And it does not give you as many options, crazy amount of options that you get in Databricks. Now, when you do want to develop, I showed you the experience inside Databricks for querying and looking at things. There is also notebooks inside Synapse as well. So for example, I can go ahead and open a notebook here. Let's say this Spark notebook, and you'll see it is a pretty nice rich graphical experience as well. It also has same thing, markdown and code cells. It has a really cool outline, so you can jump into all the different markdown cells if you want to go up and down on all of them. It has also pretty good capabilities in terms of supporting IntelliSense. You can see here reserved keyword. You can do a hover over some objects and it'll tell you what type of object it is, where is it coming from, the database that it comes from, etc. And then you can select what cluster you're going to attach the notebook to, and then go ahead and run your Spark workload. Okay, when you do have some results here, I'm going to close this notebook, open another one. And for example, here I have this Cosmos DB notebook, which is pretty cool because again, the Spark inside the Synapse Analytics is augmented as well with these special Microsoft integration bits, right? So Synapse, for example, uses this capability called a Synapse link. Now, if you know, Cosmos DB, for example, is Microsoft's NoSQL database in the cloud. And the cool thing about it is that using this Synapse link, you can bring into Spark the Cosmos DB data and do analytical workloads on them with just a few things really easy. For example, here I create a table using this cosmos.olap provider, and I give it a couple of options. I pass in a Cosmos link service, so I have defined this object before in the Synapse workspace, and I give it a container, and then I can just run a select query, and automatically behind the scenes, the Spark inside Synapse Analytics goes out and fetches the data from the analytical store of Cosmos DB and brings it in for me to do compute. So this is something that is a feature of Synapse Analytics. It's not available anywhere else, right? So it's something to keep in mind again when you're trying to select between doing Databricks or doing Synapse Analytics. If you are really strongly bought into the other pieces of the Azure ecosystem, like Cosmos DB, like Azure SQL Database, for example. Synapse Link is in preview at the time that I'm recording this. The new SQL Server 2022, is also going to have Synapse Link enablement. So if you are investing in all these other things, then it might make more sense for you to select Synapse Analytics so that you can leverage all these integrations. On the flip side, as I mentioned before, if you are buying into Spark itself, if you want to build your entire solution around Spark, if you want to do integrated Spark for the data science part, for the ML side, for the data science side, for the SQL endpoint, for the dashboarding, etc., you're going to use the whole thing, then Databricks, of course, is a huge package all built around Spark. But again, they have different purposes. You have to evaluate what is it that you're trying to build. And if you're going to use all the other bits of Synapse, like the SQL engine, the integrations with the rest of Azure, the pipeline development, and all these things, then Synapse might be a better choice for you, right? Everyone's situation will be different, but hopefully after sitting through this session, it'll give you an idea of the different approach that each one of these services has to running Spark. Okay, I hope those demos gave you a really good idea of what you get with those three main services to run Spark in Azure. Remember, it's HD Insight, Databricks, and Synapse Analytics. Now again, to reiterate, in my opinion, most people should select between Databricks or Synapse. Now it is a hard choice. You have to pick based on your requirements. If you want to build a solution that is truly Spark centric and you're going to adopt all the different layers of Databricks, then for sure, go with Databricks. However, if you are thinking of just adopting a part of Spark, you're only going to use Spark for, let's say, only some transformations, and you are more of a heavily SQL user and would like to use the MPP engine inside Synapse, you also would like to develop the pipelines graphically inside Synapse, then maybe lean towards Synapse and just use Spark as a piece of your entire solution. Regardless of which one you select, you will have a feature-rich experience because of the really rich environments that both Databricks and Synapse give you in Azure, and they're both great for learning Spark as well. So if you have been listening to this big data Spark for many years and you haven't figured out how do I just simply start learning it, pick either one, Databricks or Synapse. Follow along with some of the learning material that is online. Either one of them have galleries with lots of starting up notebooks, and you'll be able to be a Spark expert in no time. Special thanks to Microsoft for supporting Data Platform Geeks and SQL Server Geeks community initiatives. And thank you. There's 3 ways to win prizes. Post a selfie with the hashtag DPS2022. Give session and conference feedback, visit the sponsors and the exhibitors, and follow on Twitter at the Data Geeks and at Data AI Summit. Now, as I am wrapping up the session, I'm also available in the chat for a few more minutes to answer all the questions that you guys might have. So, let's do it. And until next time, thanks for watching.